we covered all the business analysis in terms of what could be the process efficiencies, what could be the best utilization, which destination or centers needs to be like given specialized treatment, which route needs to be optimized, what time of the day should we focus on to improving the efficiency and so forth. Now let's have a look at few of the predictive analytics we can do to help more in better efficiency or better delivery for this transport problem. Um, for the first problem that we are going to target is to predict the actual time. Given that we have all the features, given that we know the route, given that we know what is the segment time and other related features, can we predict actual time? And if we can, then to what accuracy we can predict? Because if the accuracy is not high, so there is no meaning of any prediction, right? So for this, the what are the features that we are going to look at from an operational point of view? We are going to look at route type, factor is cutoff, and cutoff factor. From a distance point of view, we can use actual distance to destination, OSRN distance, source center, destination center. From a time dependent variable, we can see the trip creation time, hour of the day cutoff hour, and some of the derived features like daily ratio, movement ratio, idle ratio. So we'll start our process by converting a little bit of variable into the right format, or basically the step which is called as pre-processing, and we are cleaning the data a little, starting off with converting all those time related features into date time format, making sure that the actual time is in numeric, and we are getting into target hours by dividing it by 60. The predictors like trip creation hour, trip creation date of week, and cutoff hour, we are putting it into hours and day of week, and this we are putting into date timestamp. Then route matrix, for example, like the OSR and distance, OSR and actual distance to destination, and route distance ratio. So this is this we are getting by OSR and distance by actual distance to destination, and cutoff we are converting into true or false, right? And route type we are putting it as categories, and categories we are doing a categorical like encoding here. We will get two categories, which is full truckload and half truckload, and we are grouping the rear centers into one. So basically what's happening over here is that there is a function defined rear group, and we are passing this source center to this rear group, and it will do a value count, and if the count is coming out to be less than 50, then we are tagging it to others, and for others same treatment is given to the destination center, and then for that we are calculating the mean of the actual time of the others, and for same treatment given for the destination center. And then finally we are merging this to our main data frame, mean delay by source, right? Mean delay by destination, we are merging it to our main data frame. And before getting to this, let's have a look at our final data. So we have all these features we already had. Let me point out which were the ones which were converted. For example, is cutoff is now 1.0 format, and we have a trip creation hour. Now we have date of week, we have cutoff hour, we have distance ratio, we have source center grouping and grouped into others, destination center grouping, which were having a count less than 50, they were grouped into others, and what is the source actual and what is the destination actual time. Now let's do a basic regression. For this regression, we are selecting these features: OSR and distance, actual time. Now, the objective shouldn't be at this point to be to get the most accurate prediction, or spend a lot of time in trying to improve our accuracy. We'll start with a base model, use all the relevant features that we think might help, and then our main objective is to draw business insights from it, right? So features we have selected: OSR and distance, all the distance related features, then some of the engineer features like route distance ratio, and chip creation hour, day of week, cutoff hour, and then this is making our x, and the target r, which is the actual time, actual dependent variable, we are making it as ry, and categorical variable, we are doing categorical encoding, and numerical features, we are filtering it out. Test train, this is the step for doing a test train split. We are doing a point 2, which means that 80% of the data would be pushed in the test, and 20% of the data will be trained. And all these categorical features that we just extracted here, we are doing one hot encoding, and for numerical, we are just doing a simple pass through, and model that we are using is XGBoost regressor. To be on a safer side, I know I could have started from linear regression and maybe a tree based model and then come on to XGBoost, but I know this is going to give me a good result. So I started with this first, and these are all the hyperparameter related to the XGBoost, that estimator should be 400, learning rates should be this. All this are hyperparameter related to XGBoost, and then finally we are making our data prediction pipeline, where preprocessor will be in pred and our model will be part of the model, and on this pipeline we are fitting both data, and then we are evaluating basis on our R score and a mean absolute score. So we see that the accuracy is quite high. This could also mean that the data was force fitted or overfitting case, but I'll make another video of how to like take care of overfitting, or if it is actually a case of overfitting. That is a video for different time, but as of now, but we can say that at least with 98% confidence that we would be able to predict, given that all these features we know. If we know all these values, we should be able to predict the target hour, or basically the time it will take for it to get delivered. And let's try to look at the distribution of the error. I'm getting an error over here, and I fixed that error. And from the distribution of error, you can see that the mean error is around 0, and visually also you can see most of the error is around 0, so which is a very good indication, which means that we can go ahead with our prediction, and it will be right. Okay, now let's discuss like what, once we have done the prediction, what is, how can we use this? So use case could be dispatch ETA prediction. We can generate ETA at a trip creation and feed it to operations UI. Or so ultimately, people, when they are told that their item will be delivered in 5 days, that is the prediction that they get. And if actually the item is delivered in 5 days, so their satisfaction index goes up, right? They are very satisfied with the result. So this can be used for ETA prediction. This can be used for a pre-dispatch exception, that will flag trips which have a predicted time 1.3 times more than OSRN time. So like once we are able to identify that okay, for this trip it will take a longer time, we can take some measures to avoid that delay. And then on that route it can rank lanes source to destination, and it will also help in driver scheduling and dynamic uh, routing. So this was about predicting the actual time. Next we will look into the demand and load forecasting.